So we have what's called a similarity transformation. Just checking the notation, make sure I've got the same notation the book uses, okay? So, again, we've got some vector space V here, okay? And you got the same vector space V here. Got a vector space W here, and it's the same vector space W here. But in this space, you're representing, well, then you got the transformation. And it's the same transformation. Whatever your rule for the transformation is, it's going to work relative to any basis, okay? But you have to represent it differently with different bases. Okay, and we've seen how that works with change of basis in chapter 4. Okay, so we got some vector V over here. It's got representation V sub B, where B is some basis, okay? And it goes by the transformation over here to a vector that we'll call TV, which over here we're again representing with respect to basis B, okay? Now we know that there's a change of basis matrix, okay? We know how to get the change of basis matrix if we know what the two bases are, okay? So we have the vector that I called P the other day. It's really P inverse that takes transformation with respect to B prime to the, or takes a vector with respect to B prime to a vector with respect to B. Now, the vector you're mapping here is the same here as here. It's just has different components relative to this basis. And the vector that you get over here is the same as the vector that you get over here. It just has different numbers because you're using a different basis here. So the representation of this vector is different here and here. The representation of this vector is different here and here. And the thing that connects the representation is the P inverse matrix in this case. Okay? Well, if P inverse takes the representation here to the representation here, then what takes this representation to this one? P, obviously. Okay? That's called a commutative diagram. I was looking for in the last section where I thought it belonged, but I've noticed your book didn't do that. Okay? Better to just see this and then understand everything in terms of this. Okay? Because you already understand change of basis. So, the question is, what's the matrix here? Okay. Well, let's just call this matrix for the moment A prime. Okay? So the matrix A prime is the one you have to multiply whatever vector this is, that same vector in both spaces, or both representations, but represented differently. Matrix you have to use to take this representation to this representation of this vector and this one. Okay? Okay, well, it looks like then that, first of all, A, V, B equals TV with respect to V, right? And right? Okay. And if this matrix is A prime, you can calculate this by just applying the matrix A prime to VB prime, right? TV with respect to B is just P inverse times TV with respect to B prime, right? And all this implies then VB prime is PVB, right? So A prime VB prime is A prime times PVB. And then if you do P inverse times PVB prime, you get back down to this one, right? So that to get from here to here, you can apply this, this, and this in turn. P, A prime, P inverse. Okay? So okay? And then, so what's A prime?
Let's see. A times P inverse.
No. Now they're trying to solve this equation for A prime.
P inverse times P is just the identity.
Yeah, but P inverse doesn't get multiplied by P. Matrix multiplication is not commutative. P inverse is never going to be next to P. Yeah, I know. Brain misfire. Okay?
Yeah.
So what are you going to solve this for A prime? What operation would you do, or what series of operations would you do to solve this equation?
Row reduction.
We don't know the, no.
Let's see. What? That's
Like what operation would we do to both sides of this equation to get it closer to being a solution for A prime?
multiplied by P.
Okay, so A prime,
Hey Dave, is it okay if the air conditioning guy comes and looks at a unit?
it'd
You
be
got
just,
class coming?
it'd thrill the heck out. I'm gonna be done in 1 minute.
Okay,
I'll be done before he gets here.
okay, thank you, sir.
Sure enough, Eddie. Okay. Yeah, we do need that unit fixed. Okay. So, I mean, it follows that A prime equals PA, P inverse. You just multiply left by P, you get PA, right? Then multiply on the right by P inverse, you get PA, P inverse. And you've isolated A prime. Okay? So, that's much simpler than what you were thinking.
Yeah.
You want to get your hands too dirty. Okay? So we've got this. Okay? That makes sense? Well, I'm going to leave you with that, and I'll assign a few problems that follow reasonably what we just talked about. Okay?
No.